Welcome student with a new topic multiple integral. In that multiple integral, first you see the double integration, means double integral. How to evaluate double integration, means evaluation of the double integration. So let's see, if I equal to double integration f of xy dx dy, and here we have to decide the limits. So here randomly we have taken x1, x2, y1, y2. But how to decide this? So there are three cases. So which are these? So case number 1, when the limits y1, y2 are the functions of x and x1, x2 are constant, then integrate with respect to y, first keeping x as a constant and then result integrate with respect to x. So what is the meaning of it? How to decide this? How we can say that is y1, y2 are functions of x and x1, x2 constant. So let's see here one figure and geometrically meaning of that. So here in that figure you can see region of integration. It means that first by the given curve you find the region of integration. So definitely in that region there are maximum 4 boundaries, and out of these maximum 2 curve path and remaining straight lines. So you can see here the region of integration. So draw the region of integration bounded by the curve. It means that these are the given curves y1, y2 and x1, x2, and take a strip. So here we have taken vertical strip SR. Why? Because you have to take either vertical strip or horizontal strip, right? Means strip parallel to x-axis or parallel to y-axis you have to take. But which strip is applicable there? So note there, we have to take a strip such that this is a boundary of this strip and this is second boundary of this strip. It should touch to curve path if there. So here if I am taking horizontal strip, so it is not applicable. Why? Because it not touch to the curve path. So which are the boundaries here? You can see this is the first boundary, this is second boundary. If we continue, this is third boundary and this is the fourth boundary. You can see. And now I want to take a strip, either vertical or horizontal, but that strip should touch to the curve path if there. So here like this is a curve path and this is a curve path. So only one option we have, that is a vertical strip. One more thing you have to remember here, if I am taking a vertical strip, so it should be same from this to last. Here suppose one may consider like this. So this strip, it means that anywhere in the region keeping parallel to y-axis, it means that it's a vertical, but anywhere in the region. So boundaries should be same. So you can see here boundaries is curve to curve, here again curve to curve, here again curve to curve. So here I can take vertical strip, that is applicable. So what is this strip? You can see this strip means what? So here this strip, here I am taking the width of this is a delta x, very small, tends to 0 you can say, and that is why along this strip if it is a tends to 0, the value of x is a constant whatever there. If I am taking a here the strip, then x is a constant, but values of y are different. Here different because I am getting different point of y. Getting? So along this strip x constant and y varies. And y varies from which point to which point? You can see always in positive direction of y we consider. So that is why y varies from this curve to this curve. Means point S to point R. So what is point S? It is nothing but a curve path. y1 equal to f1x, y2 equal to f2x. Means these are the limits of y. So when we are taking a vertical strip, then x constant and y varies from lower curve to upper curve. These are your first limits of y, and that is why take a vertical strip as shown in figure. Along the strip x constant and y varies from S to R. It means that is y1 equal to f1x to y2 equal to f2x, and it gives, that is I am going to consider here y1 to y2. It means that these are the limits of y. You integrate with respect to y first inside, just like a single integral, keeping x as a constant and whatever the result you find here. After that, again you consider the figure. Now keeping parallel to y-axis, vary this strip like this, but keep this strip parallel to y-axis. Okay, and that is why what are the boundaries of x I am getting? This straight lines, and that is why you can find this x equal to a to x equal to b. These are the limits of x, and it gives us this integration x1 to x2. It means that now varying the strip throughout the region keeping parallel to axis, therefore x varies from x1 to x2. It gives integration x1 x2, supposed to be this result we already have by this evaluation, and keep here, and this is just like a single integration with respect to x you evaluate, and it gives your result. Now one more thing I can, in simple way I can explain it the same thing. Here see the figure, then you decide the region of integration, then you take a strip whether vertical or horizontal, you know the why, that it should touch to the curve path, means curve boundaries. So if we extend that strip, it cut to any one axis, so it cut to x axis here, and that is why y varies and x constant, right? It cut to which axis? X axis, that is why x constant, and y varies, so that is why you find the boundaries of y, y1 to y2 means by using the equations of curve, and after that you find the boundaries of that curve on the particular axis. So it cut to x axis, so on x axis you find where it curve start and where it ends. So here a to b, so I am getting here a to b. So by using this also you can decide the limits of double integration. Now case number 2. What is that case 2? When the limits x1 x2 are functions of y and y1 y2 are constant, then integrate with respect to x, first keeping y as a constant, and then result integrate with respect to y. So what is the meaning of it? So geometrically I am getting such type of figure. It means that again draw the region of integration by given curve. So again there will be maximum 4 boundaries. Out of these maximum 2 curve boundaries, here we are getting 2 curve boundaries, this one and this one. So I want to take a strip either vertical or horizontal. If I am taking vertical strip anywhere, I am not taking here. If supposed to be I am taking here. So what I said, that anywhere you can take, limits should be same. But here I am getting different, but here boundary is different. Here curve to curve, but here line to line. And that is why vertical strip is not applicable there. And second thing you have to remember that strip should cover the curve path. So here like this. So only one possibility, that is the horizontal strip. So width of this strip is the small or tends to 0, and that is why value of y at that particular strip is a constant, and that is why we can say take a horizontal strip SR as shown in figure, and along this strip y constant, and x varies because y x varies from this point, this point, this point, this point. Values of x are different, and this varies from curve to curve, means S to R, means what? This boundary to this boundary. So curve boundaries are there. So by equations I can find the boundaries, that is here along the strip y constant and x varies from S to R. What is the meaning of that? That is x1 equal to f1y to x2 equal to f2y. You can see here. So it gives I equal to integration in bracket x1 to x2. So these are the limits of x. So first integrate with respect to x just like a single integral. And after that varying this strip throughout the region keeping parallel to x axis. Therefore y varies from y1 to y2. So what is this one? It means that if we keeping this parallel to x axis and just vary like this. What are the boundaries here? I am getting y equal to c to y equal to d. Boundaries, here the boundary and here the boundary. So y equal to c to y equal to d. Therefore it gives like this. I equal to y1 to y2. We already have this single integral, we already solved. This result is here, and this integration, whatever that, just like a single integration with respect to y. So easily you can evaluate. Sometimes case number 3 now. What is the case number 3? If all boundaries are constant. So when limits x1, x2 and y1, y2 are constant, then integrate with respect to any variable. Keeping second variable as a constant, then result integrate with respect to second variable. So here you can see the figure. So all boundaries, there are 4 boundaries and all boundaries are straight lines. It means that there is no curve boundary. So in this case, I can take any strip, but condition only is that from this corner to last corner, I am getting same limits. So here I am getting same limits means x1 equal to a and x2 equal to b. So here I can take vertical or horizontal strip. So here in the first case, y1, y2 means y varies. So which strip I am taking here? Definitely vertical strip. Y varies and x constant x1, x2. So similarly, I can take horizontal strip and I am getting this type of region. You also note that if the region R is R equal to R1 union R2, then double integration f of xy dx dy over R is equal to double integration of f of xy dx dy over R1 plus double integration of f of xy dx dy over R2. It means that sometimes we have to divide that region into 2 parts and then you take a integration, means double integration of that first region, then double integration of second region, and you add that double integrations, then you will get the double integration of whole region. So without fail, you remember these 3 cases, then easily you can evaluate double integration just like a single integral. So let's consider some examples on it, so it will be more clear. Now consider the example on double integration. Remember, there in double integration there are 4 types of examples. First, very simple, that limits are given, directly evaluate by the sequence. Second, limits are not given, we have to decide the limits by using the strip. Third, limits are given but in the given order not useful, so we have to change the order of integration. And fourth is, sometimes we have to convert into polar by using polar transformation. So definitely we will solve that type of examples also. So here the simple example or simple type, evaluate integration 0 to 1, inner integration 0 to x square plus 3y dy dx. So note that if inner integral contains x, it means that these are the limits of y, because for example curve y equal to x to y equal to x square. So I am taking limits as x and x square. It means that it contains x and x square here. These are the limits of y. So definitely inner integral contains x means these are the limits of y. So first integrate with respect to y. So how? Solution. So I equal to, given thing I will write again, that is integration 0 to 1, integration 0 to x square plus 3y dy dx. So here sequence is that first integrate with respect to y. So only y you consider inside, means in the bracket. So integration 0 to x. So here we cannot separate it, that's why both things you consider. But you remember, we have to integrate with respect to y first and then x, whatever the result, then x. So in inner integral means, it means that in the bracket only y active, x constant, and that is why integration with respect to y. So x square is a constant, so I am getting x square into y plus 3 y square by 2. What are the limits? 0 to x. So don't forget, these are the limits of y. So y replaced by upper limit minus y replaced by lower limit. So that is why I am getting I equal to integration 0 to 1. Upper limit is x, so I am getting x square into x plus 3 x square by 2 minus lower limit, as y equal to 0, I am getting y 0 plus 0, because if we put here y equal to 0, so I am getting 0 plus 0. So simplify this and you will get a single integral, and that integration with respect to x. So you can see, even though double integration, it is very easy, only systematically or stepwise you evaluate. So here I am getting, it is a x cube plus 3 by 2 x square into dx. So now integrate with respect to x. So I am getting x raised to 4 by 4 plus 3 by 2 x cube by 3. Lower limit is 0, upper limit is 1. So upper limit minus lower limit. It means that x replaced by upper limit minus x replaced by lower limit. So here upper limit is 1. So 1 by 4 plus 3 by 2 as it is. As x equal to 1, I am getting 1 by 3 minus now lower limit. If we put x equal to 0, here x equal to 0. So I am getting result is 0. So this cancel, and by evaluation 1 by 4 plus 1 by 2 I am getting, and the result of it is nothing but 3 by 4, which is your required answer. So to evaluate double integration without fail, we should have the integration formula. So you must see or go through the all formula of integration. Now consider one more example, that evaluate integration 0 to 2, integration from 1 to y, yx dx dy. So you can see here inner integral contains y, means these are the limits of x. So first integrate with respect to x, keeping y as a constant, and whatever the result there, you integrate with respect to y. So I am getting here, so you consider that integral I, integration 0 to 2, integration 1 to y, xy dx dy. So now inner integral contains y, means first integrate with respect to x. So integration 1 to y. So only x inside. So x dx, I can take this y outside. So y dy outside. Now integration 0 to 2, and here integration with respect to x, I am getting x square by 2. Lower limit is 1, upper limit is y, and y dy constant. So here 0 to 2. So here upper limit minus lower limit. So y square by 2 minus 1 by 2 I am getting, and y dy as it is there. Simplify this. So I am getting 0 to 2, and here y cube by 2 minus y by 2 into dy. So what is the integration? It's just like a single integral. So integration with respect to y, so I am getting y raised to 4 by 4, already 2 there. So that is why 2 into 4 minus, again here integration of y by standard integration, y square by 2, already 2 there. So I am getting 2 into 2. Lower limit 0, upper limit 2. So take here upper limit minus lower limit. So y replaced by upper limit. So I am getting 2 raised to 4 by 8 minus 2 square by 4 minus lower limit is 0, that is why y equal to 0. So I am getting 0 minus 0. You can evaluate or you can use your direct steps also. That depends on you. So I am getting here 2 minus 1 and 1, that is equal to 1. So I equal to 1 is your required answer. So how simple this evaluation of double integration. But sometimes we have to decide the limits of double integration. So how? So definitely we will consider examples on that also. Now see the one more example on it, that evaluate integration 0 to 1, inner integration 0 to 1 dx dy under root of 1 minus x square into 1 minus y square. So how to evaluate this? Very interesting. Here both limits, means outer integral and inner integral, both constant, 0 to 1, 0 to 1. It not contains any variable. So how to decide the sequence? So if limits of both integral are constant in the given double integration, so in that integral you evaluate by the given sequence. It means that here dx first and dy second. Sometimes if supposed to be different there, they may consider, or example itself contains dy dx. So in such example you integrate with respect to y first and then x. So here dx dy means first integrate with respect to x and then result with respect to y. So again the similar solution, you consider I means integral, integration 0 to 1, integration 0 to 1 dx dy under root of 1 minus x square into 1 minus y square. Note that the same thing I can write integration 0 to 1, integration 0 to 1 dx dy, and I can separate this under root of 1 minus x square into under root of 1 minus y square. So first we have to consider integration with respect to x. So only x inside, remaining outside. So 0 to 1 integration here dx under root of 1 minus x square here, and dy upon under root of 1 minus y square constant outside. So only bracket you consider as a single integral and evaluate with respect to x. As we know by the standard integration, it is the integration of sine inverse x. So that is why I am getting here I equal to integration 0 to 1. So it will be a sine inverse x, lower limit 0, upper limit 1, and dy upon under root of 1 minus y square as it is. So upper limit minus lower limit means here replace x by upper limit minus x replaced by lower limit. So by the standard values I am getting I equal to integration 0 to 1 this, and here it is a pi by 2 minus 0, and dy upon under root of 1 minus y square as it is. So pi by 2 is a constant, so take outside integration 0 to 1 dy upon under root of 1 minus y square. So again by the same formula I am getting it is a sine inverse y, and here 0 and 1 limits. So again by the same or similar we can write it is a pi by 2 as it is here, sine inverse 1 it is a pi by 2 minus sine inverse 0 is 0. Directly I am taking now. So I am getting here I equal to pi by 2 into pi by 2, that is why pi square by 4 is your required result.